In this particular demonstration, we look at how to use association rules using XLMiner. You must have already downloaded XLMiner, which is a plugin to Excel. First, let's open the file called faceplate. This is a file that talks about 10 customers having bought 6 different color faceplates for their cell phone. This used to be a rate of buying different faceplate to put on their cell phone depending on what clothes they wear. Of course, now it's you don't see many people doing it, but it used to happen early 2000. So here we have 6 colors and 10 transactions. Each transaction is about a customer buying different color faceplates. In row number 2, you can see that the customer bought red, white, and green, which is 1. If it is 0, then they have not bought that. So you see 10 customers having bought different colored faceplates. The question here is, can we look at this and say something about association rules? That is, if X, then Y. You might notice that if somebody buys green, then you see them likely to buy both red and white. So customer 1 has bought green, has also bought red and white. Likewise, customer 8, which is row 9, has bought green, has also bought red and white. So we might say with confidence, if somebody buys green, they are likely to buy red and white. Now if I ask you to go and pull up all the different rules, it is not easy. You can have any number of combinations with different confidence level. So let's look at XLMiner, and if you click on this particular link here, you can find association rules. Now association rules can actually pick up all types of rules from any given data sets. I would encourage you to read what these mean. Data source, sheet 1, that's what it says. Data range, it should automatically pick up the entire data row, data set here. If not, you can manually select the data range. It identifies number of rows and number of columns. The first row contains the headers, which you have to check mark. And the data is in binary matrix format. Binary means 0 or 1, yes or no. In this case, it's 0 or 1. So data is in binary matrix format. XLMiner automatically picks up 20% of the transactions for minimum support, which means any rule you pick up, it should have a support of at least 20% of the number of transactions. Since we have 10 rows, it picks up 20%, which is 2. Then you have minimum confidence percentage, which is 50%. If you recollect, this means the probability of buying something given you have bought something else. So if X implies Y, we are looking at probability of Y given X. To make it easy to understand, let's look at the language XLMiner uses. It uses X as antecedent, Y as consequent. That is, if antecedent, then consequent. Antecedent is represented as A, consequent as C. So now we want that to be 50%. So let's look at pick 50%, or you can try 70% if you want. Let's pick 50% to begin with. So what it does, if you click, automatically calculates the number of rules. There are 16 here. And if you go back and look at it, it has identified 16 rules here with different confidence levels. For example, we gave in one where if you buy green, likely to buy red and white. So antecedent is A, the consequent is C. So if green, then red and white. Now let's look at what this 100% mean. We said this is nothing but probability of C given A. So how do you calculate that? Which is nothing but the number of transactions that has A and C given by divided by number of transactions only with A. So what this means is, now if you look at the number of transactions that has A and C is 2, and the number of transactions that has only A is 2. So 2 divided by 2 is equal to 100%. That's what you have here. Now, what is most important in this particular rule is to look at what we call the lift ratio. Now, what does lift ratio mean? What is the likelihood that this red and white, somebody is going to buy red and white if they buy green? So what is the likelihood of that increasing if somebody buys green? Which means if somebody walks into your store, they might buy red and white, and there is some probability of that. But what happens to that probability if you have already bought green? That's what you're trying to find, lift ratio. So somebody buying red and white, how do you calculate that probability? So we know that there are 4 customers who have bought red and white. So the probability of somebody buying red and white is nothing but 4 divided by 10, which is 0.4, 40%. The question now we have is, what happens if they buy green? What happens to the probability of red and white? Now, that's lift ratio, and it's 2.5. And how did they calculate 2.5? We know the probability of somebody buying red and white, given that they bought green, is 1. So this is 1 divided by the probability of buying red and white. That is 0.4, which is 2.5. That's the lift ratio. So in selecting the rules, there may be many different ways to select them. One, look at confidence percentage. You want it to be higher or even close to 0. In this case, we don't pick that. Then look at lift ratio. You want the lift ratio to be greater than 1. Anything less than 1, it is not giving you any new information. We want the probability of that consequent to go up if somebody has bought the antecedent. That's what the lift ratio says. So lift ratio is important. Confidence percentage is important. Sometimes there may be lots of rules with ties. How do you break ties? Then look at number of transactions they impact. If they impact more number of transactions, then it is of more value to you. You want to become even better in picking the rules, then you want to look at the margin or the profits you make. So more profits you make from a particular product, then you probably want to pick it. So there are many different ways to select the rules. Look at confidence percentage, look at lift ratio, look at the number of transactions they impact, or look at the amount of money you make or the profits you make. So if you take arbitrarily any data set in some format, we should be able to pull these rules, and that's what association rule does.